Hello. I would like to share my experience in integration of trig functions, which is a rather basic training in calculus. Now, today I would like to talk about sine functions, sine power n. Okay. And you can do similar for the cosine. Now, let me increasing n one by one. We're dealing with sine function, sine square, sine cube, sine fourth, sine fifth, sine sixth, until you have a general idea, You have an idea in general to deal with the sine function. Okay, when n equal to 1, that is nothing to talk about. That's basic. Is equal to a negative cosine x plus c, right? See, that's nothing to talk, but that's basic. And then now sine square x dx. Now the problem here is that you are dealing with two functions, a square function and a sine function. So you have to solve these two problems one at a time, right? So here, obviously that we are using the basic trig identities. See, this function, this identity, you can reduce the square into first power. This for cosine, right? So that is solve your problem of a square function. So this one is equal to 1/2 integral, right? 1 minus cosine 2x. So no more square function. That is a problem we solved. Then this is equal to 1/2 integral, right? So dx minus integral cosine 2x, right? Now here, also you have two functions. One is a 2x, the other one is a cosine function. So we have to solve problem one by one. You see? So here I just to solve to absorb this 2x into one variable, change the dx into d2x, then this becomes just purely cosine function. But this one is a 2dx. We have only 1 dx, so you multiply times half again. So this becomes 1/4, right? Yes. Then this equal to 1/2 bracket. This is x, right? This is the integral of a sine. Cosine is sine, right? So 1/1/4 sine 2x. Yeah, plus c. So the integration is done. Here, I forget the u business because this is simple, and you don't have to let the u be 2x, and afterwards you put a u back. Okay, this is cosine. This is sine square. Now sine cube x dx. Yeah. Here, the problem is that you are dealing with two functions, cubic function and the sine function. So you have to solve one problem at a time. Okay, now what I'm going to do is this. I put a cubic is equal to sine square x and the sine x, and then dx. And it could look. I noticed this is derivative of cosine, right? This is derivative of cosine, but a negative. I put a negative outside. Okay. So that means I change my name of game. I'm not integrate I'm not integrating with respect to x. I'm integrating with respect to cosine. Cosine is my basic variable. So in front, I have to change everything in terms of cosine. If I could, I win. If I couldn't, then you have to do something else. So here, fortunately, I could. This becomes cosine square x, right? So I do change the integrand function in terms of cosine. So then this is done, right? This is minus. This becomes cosine, right? Cosine x. This becomes 1/3, right? Cosine theta plus c. So that's been done because this is a square function. You're dealing with cosine x, so cosine square becomes something cubed. So that is now here. Now I just omit the u business. Let the u be cosine and so on. This is not necessary because it's rather straightforward. Okay, next one. Sine fourth. Sine fourth. X dx. You are dealing with two problems here. One is the power function, one is the sine function. So you change one of them, either reduce the power or change the structure. Reduce the power, that means reduce the force into lower power. Change the structure means I change x into some variable, which you dissolve that sine function. So here, of course, you need some experience. That here I have nothing to do but to reduce the power, right? So this one is equal to integral half, right? This is 1 minus cosine 2x. That is sine square and square again, right? So I reduce the power from fourth to second. So this one equal to fourth integral 1 minus 2 cosine 2x plus cosine square 2x dx. Okay, so far so good. Then this is a 1/4 integral, right? This is a dx. This is a dx minus 2 integral. Now here is a cosine 2x, right? dx. I change the dx into d2x, right? Times half. So this becomes dx. And this is just purely cosine function. There's no complex function, composite function here. This becomes integral, right? This is 1 plus cosine 4x dx. All right, so far so good. And it's dealing one by one. This is a 1. This becomes x. It becomes a 1, right? Cosine integration is a sine, right? Becomes a minus sine 2x plus 1/2, right? This integrals dx. This becomes plus integral cosine 4x, and I change this one to 4x as well. And I have only one dx, so I change it, I balance it by times 1/4, right? So this one equals to 1/4 x minus sine 2x plus 1/2 x plus 1/8, right? 1/8. Now this is a sine 4x, right? Let's see. Yeah, of course you can simplify in the algebra. I don't come up. Okay, the integration has been done. Now we look back at that. The strategy we are adapting here is reduce the power. That is the sine fourth. The next one is sine fifth. Sine fifth. Sine 5 or fifth power. You are dealing with two functions, sine function and the fifth power function. Okay, you solve these two problems one at a time. Either reduce the power or change the structure. Change the structure means I change it from x into sine x or cosine x. Here, obviously this is equal to sine 4th x, right? Sine x dx. See, I'm preparing that. I prepare this is the derivative of cosine. So I change this one to d cosine x, and the negative, right? Negative. Now the function here has to change in terms of cosine. If it's possible, then you're done. If not possible, then use some other method, which is possible, right? Because this is 1 minus cosine square x square, right? Understand? This is sine square, sine fourth. So this one is equal to negative 1, right? 1 times this is a d cosine x, right? 1 times this one, minus 2 cosine square x d cosine x, right? Plus 1 minus the last one is plus, right? Cosine 4x d cosine x. Well, everything done. You expand this one into 1 minus 2 cosine plus 1. Yes, that's done. Okay, then this is equal to negative. This is the cosine x. And this one is equal to cubic, right? Cosine cube x, yeah. Plus, this is 5 cosine 5x plus c. Okay, the integration has been done. And if you want to simplify, just algebra. Okay, now I summarize again, okay? We are dealing with this kind of function. We have two problems, power function and trig functions. How to solve this one? Either reduce the power or change the structure. In this particular integral, I change the structure. That means I change the game from x into cosine x. So here I'm dealing with x. here I'm dealing with cosine x. So there's no longer being trig functions. These polynomials. So I think this is a very, very important, very good training for basic function in trig functions. Okay. Now I think you should have enough experience. Now next one, 6, right? Obviously, we have reduced the power, right? And once you know the strategy, just implement, just do it. You know, the theory is not easy. The calculations are just trivial. Just follow your idea. See, this one is equal to what? This one is equal to 1 minus cos 2x, right? So that's the sine square, and 3, right? Then the power has been reduced. Then this is equal to 1/8, right? And then this is just cubic function, right? This is 1, right? Minus 3 cos 2x, right, plus 3 cos square 2x minus cos cube 2x. Yeah, integral dx. See, this function for integration is not easy because very high powered. But now the power has been reduced. Okay, I may not do the details. I just do. Okay, this could be done. Dx is x. This could be done, right? This simply change it to 3 cosine 2x d2x, right? And times 2 here. Then this could be done. And here, I reduce the power again. This is 3, 2, 1 minus 1 plus cosine 4x, right? Yeah. So this integration can be done again. This one, like dealing with the sine cube, change the structure. Change this. For this one, change the cosine square 3x, 2x, sorry, 2x, and cosine 2x dx. And change this one to sine. This one becomes d sine 2x, right? And put it 1/2 outside. Then change this one to 1 minus sine square. So everything can be done. All right. So that is the method in general to deal with sine. See, let me go back again. So we are not afraid of this function in x. When n is even, we reduce the power. When n is an order, we change the structure. All right, so this can be done nicely. I'll repeat again. When n is even, we reduce the power. When n is order, we change the structure. Changes x into cosine. So we can do in general. Now you can do yourself with this function, right? So this next one is that the combination of sine and cosine. Integral sine m function nx cosine nx. Okay, now let's think that the cases. How many cases could be? M and N could be both even. M and N could be both order. And M and N could be one order, one even. All right. Let's do stuff from both are order. Okay. For example, now I just show you one example. You can understand how to deal with it. Say sine 3x, right? Cosine 5x. Just for example, okay? Now you have choices. You can change the function into sine, or you change the function into cosine, because both are order functions. Now I choose the least one. I don't know. I show you the reason later. Okay, this cosine 50. This is a sine square x and the sine x dx. Right? Okay. The reason is this. I prepared this one, change it to the derivative of cosine. And I change everything in the front into cosine. Then I succeed. So this one is equal to negative because it's negative, right? This is a cosine 5. This is a 1 minus cosine square x. Okay? Now change it to this one. This is very easy. This is a polynomial, right? It's a negative cosine 5x minus cosine square x 7, right? 7x d cosine x. Yeah, this when you change the variable from x into cosine x, then this is no longer being trig functions, just a polynomial. So that becomes very easy. Negative 1/6 cosine 6, right? Plus 8 cosine 8 plus, see? All right. Of course, you can simplify a little bit algebra. Now, you can also do this. I'm not changing to cosine, I change to sine. This is also okay. This becomes sine 3x cosine 4x and the cosine x and the dx. Well, I can do this way, right? See, the reason this becomes the derivative of sine. So I change the structure, that means change the function in terms of sine function. Then if I can change this into sine x, then I'll succeed, which is equal to sine x. This is 1 minus sine square x squared, right? Now then it's done. You expand this one, then multiply in, then do 1 by 1. See, the reason I choose cosine in first place, because this power is lower than this. This is fourth. You need another expansion. You need another expansion of polynomial. Here I have less problem, so I choose the lower one to reduce the. I change the lower one to change the variable instead of the higher one. But both okay. I hope you understand me. Okay, so next one is both one even, one order. One even, one order, okay? Sine 3x, cosine 4x. Now here, I know that which one I'm going to do. Because this order, I can change the structure, right? This becomes cosine 4x sine square x, right? And sine x dx. And I change this one into cosine, you see? Changing this one to cosine. And that becomes a negative. Okay? If I can change the function in terms of cosine, then I succeed. It is possible. This is cosine fourth. This is 1 minus cosine, right? Then everything's done. See, this integration is a 5, right? Cosine 5. This is a 6, right? Plus 7x. See, that can be done nicely. Okay, finally, they're both even. Sine square x, cosine fourth. Both are even. And of course, there's no choice. You have to reduce the power. Can we... Yeah, reduce, because if you change the structure, you will leave one function remaining order. You can change the variable nicely. So here, reduce the power. This becomes a integral, right? 1 minus cosine 2x times 1 plus cosine 2x bracket square dx. Here you have a power of 6, but here you have only cubic function. So this one equals 2 times 4 is 8, right? Integral 1 minus cosine 2x 1 plus 2 cosine 2x plus cosine square 2x dx. Okay. So compared with a given function, if the power is much lower, this is a 1, then you have a, well, this is just simple algebra, right? This you have a polynomial function to integrate, such that in which you have a 1, you have a cosine square 2x, you have a cosine cubic 2x, you have a cosine fourth 2x, right? So whichever one we can do it. We can change this one to d2x, right? And change on 16. Now, this we have done before, just reduce the power. This changes the variable, right? This reduce the power twice, and just simple cosine x. So all can be done nicely. So after these examples, okay, what I have done is that the sine function and the cosine function, these are just similar. You can do yourself, right? And the sine and the cosine combination of these two functions together. So these functions for integrations, these integral can be done nicely. At least you have a general idea how to deal with them, right? Reduce the power or change the structure. Okay. For the next video, I will talk about the tangent. Thank you for your watching.